you know. Okay. Yeah, cosine alpha over 2 is still possible to be positive or negative, but this, if you compare this formula with what we got here, with this, do they look like each other? Very much, right? They look very much like each other, this one and that one. So here's why I think they look like each other. So here, let's make a copy of that so that we're gonna see more of this. So make a copy of it. Here, let's go here. Paste here. Okay. So I'm saying, well, they look like each other, so I'm gonna prove it to you. It's quite. So if I factor a 2, I get this, right? This is what I get. But if I go with this, right? I multiply 2 for the numerator and the denominator, right? So this is still the same thing. They're still equal, right? So then we have 2 times 2 equals 4. So we have 4 times this stuff, right? So you see, well, now I can see it. This is that, right? This is that. And well, because we got a 4 there, we can take the 4 out. Now these two things are the exact same, right? That's that. This is the half angle, right? The half angle stuff there. Okay. So I'm gonna write this as the half angle stuff. So it's 2 cosine alpha over 2. Right? So this is the modulus. Right? The modulus equals 2 times cosine alpha over 2. This comes from one of these identities, right? So when we learn about trig, we learn a bunch of trig identities. These are 2 of those, right? These are 2 of those important trig-like identities. So if you've never seen it before, well, this is the first time you've seen it. You may remember, you may forget about it, but the next time you learn this, it's going to be easier for you because you've seen it today. And then R is the modulus. The modulus has to be positive. Modulus always has to be positive. So we're going to put a absolute value sign here. So just make it always positive, right? Does it make sense so far? Well, is it confusing now? Is it confusing?
I mean, that part, not really.
Which part is confusing?
It's like,
Aaron?
I know what you're trying to do, I think.
Is there anything that that you don't understand so far?
Not the math,
So the challenge is that when you have something like this, right, and you just make changes to it all the way to here, and I think that the one thing that is challenging is to relate this to that, right? Because they don't really look that similar when you first see it, right? It's got 1 plus cosine alpha divided by 2, but that's a constant, right? We can always play with constant. We can put it wherever we need to, right? So if this constant was outside, so even though the formula was written that way, but in your mind it should be this, right? It's a number, or it's a constant, or it's a coefficient, or whatever. That's the number. It times this, which is root 1 plus cosine alpha, right? And then we can play with this number. So when we have something like this, right? Well, it is also a constant times that, right? Or in this case is A, this is A, right? So this part and that part, these are the same, right? So we understand that they are deeply related. So when you see something like this, that should remind you of that. So that's how. That's why we need to get quite familiar with these things. It's like, well, this is. I sometimes say that math is like a language. If you are not very familiar with it, you know a little bit of it, you maybe you don't think of that formula, right? You're just, let's say you don't speak Chinese, but you can understand it. When it's the time for you to speak, and a lot of words you cannot pick up, right? Because you're not that familiar with it. Math is also sometimes like a language. If you're not very familiar with it, you can't think of this. It's not there, right? So that's probably one of the main challenges when we deal with math. But once you get familiar with that, then you feel happy about it. Oh, I solved this problem. Okay. So this becomes something much simpler here, right? So we got the radius or the modulus of this complex number. And then let's take a look at the argument of it, right? So we still use the same method to calculate the argument. Well, we take a look at arctan. And the imaginary part is sine A. Real part is that, right? So this is the I wouldn't say this is the argument, because we want the argument to be within 0 to 2 pi, right? This may not be from 0 to 2 pi, but this is the thing that helps us to find the argument, right? We use arctan, whatever the imaginary part and the imaginary part and the real part is. So imaginary part over the real part, that's the ratio, right? So whatever the imaginary part is and what the real part is, so this is the imaginary part, the real part, right? And that's the angle we're looking at. So arctan, this length over that length, will help us figure out what the angle is, right? So now when we have arctan sine A over 1 plus cosine A, and this is also something that we should be familiar with, right? If it doesn't ring the bell, and the next time when you learn trig, you pay attention to it, right? So when you learn trig, when you see this, sometimes you don't think this is important, right? You see it, well, it's just some kind of symbols mixed up, and then there's a big fraction. That's what it looks like, right? But when you can really recognize what this is, I'm telling you that this is tan alpha, in this case is A over 2. This is what that is. Okay? So that's another trig identity right? Another trig identity. Should we go here? Do I have it? No, I don't. Okay, so I have it here. So this is the graph for sine x over 1 plus cosine x, right? You can see the graph, right? It repeats. Okay. Oh, I'm lost. Jesus. Okay. So that's what the graph looks like, right? But if I turn that off, and this is tan x over 2, this is the same. Okay, these two are the exact same. So turn that back on. See? Right? These two are the exact same thing. Okay? So this is also a formula for or half angle formula for tan. Okay? Tan a over 2. And when you know the value of sine a and the value of cosine a, this is how you can calculate tan a over 2 directly. Okay? And when you learn trig, there's a task for you to prove those trig identities, right? So if you've never proved the trig identities, like you never learned it. So this is like one of the things that you need to prove. Well, we can write sine alpha as plus or minus root 1 minus cosine that squared, right? That's sine alpha. Because 1 minus cosine alpha squared is sine alpha squared. Sine a squared, right? So then you take the square root of it, you take the root for sine alpha squared. It'll give you sine a. I keep saying sine alpha, it's usually alpha. Then it could be positive or negative. You put plus or minus sign there. All right. So then you can change this to plus or minus root 1 minus cosine a squared over 1 plus cosine a, right? So this is like a trig lesson. Well, so be it. Right, because we need to learn it. Then if you learned it before, this is the review of it. And then you turn this to 1 minus cosine a times 1 plus cosine a. In case of you forget about it, a squared minus b squared equals a minus b times a plus b, right? So we applied that formula here, so we get from here to there. Right, that's and below it, well, it's 1 plus cosine a, and we can make it as root 1 plus cosine a times 1 plus cosine a, right? Okay, we can cancel one of these. Okay, then we get plus or minus root 1 minus cosine a over 1 plus cosine a root. All right. And as you've seen, that cosine a over 2 equals root 1 plus cosine a over 2, right? And actually sine a over 2 equals root 1 minus cosine a over 2. Maybe this is too much, right? I'm pouring the trig identities to you. So, Aaron?
Yeah.
Are you familiar with some of these?
Yeah.
Yeah, that's good. Zephyr? You familiar with all these?